Offering unique products is a competitive strategy that creates distinctive value, wins more business, and increases customer loyalty. However, manual design customization can be expensive, error-prone, and time-consuming. Completely embedded, the Solid Edge Design Configurator allows you to rapidly design products to customer specification while eliminating expensive errors inherent in manual design customization. This conveyor assembly needs to be customized for different length, width, and pitch values. Since the style and number of connecting plates on the underside are directly related to the size of the conveyor, this assembly cannot simply be controlled by variables alone. However, Solid Edge Design Configurator will easily allow the rules to be created to define a customizable product. The required input parameters can be defined to guide the configuration process. Here, the style and form of input is easily controlled and allows us to choose the desired drop-down menus and checkboxes and control how they will appear in the final configuration form. Values can easily be added for any of the parameters, and images can be included to help the end user identify the needed inputs when configuring the model. Defining a new input parameter for the pitch of the conveyor, we can quickly configure the name, type, label, and render styles to have the input appear as radial buttons. Pitch values for the conveyor can be customized between 60 and 90 millimeters. However, since different lengths of the conveyor require a different pitch, visibility rules need to be defined to configure when each pitch value can be used. This is done by making use of simple expressions to define the intelligence. As we do this, the function can quickly be validated with the built-in validation tool. Functions can also be copied and pasted to reuse them. Skipping to the last configuration step, we can see the configuration form is defined with the necessary picture, and the correct pitch options appear based on length chosen. Defining rules is the next step of the process. There are a variety to choose from, ranging from variable binding to simple expression and truth mapping rules. Here we have multiple rules to drive and configure the connectors at the bottom of the conveyor. In this example, we have simple conditional and expression rules to take the length of the conveyor and determine the number of connectors needed. Then a truth mapping table is used to decide whether the pitch of the connector is a fixed value or calculated based on a formula. Another rule can then be used to calculate the position of the connectors based on the length input. All rules can be quickly validated. Finally, we can specify the actions that the model is subject to. These can range from replacing a part with an alternative, renaming files, or even saving models in a different format. In this case, we need to replace the roller with a different one, dependent on the width of the conveyor. This makes use of the standard alternate components function in Solid Edge to define the two replacement parts. We'll then set some variable rules connecting our model variables defined in Solid Edge to the functions we set up as global rules in the previous steps. A rename model action will ensure that our final assembly will be renamed appropriately, and also create the other necessary outputs, for example, step files as shown here. The order of these actions can also be easily changed. Once the configuration is complete, we can run it and quickly create as many different custom variants of the conveyor as necessary. Any newly generated configurations can be easily shared with Pack and Go. The configuration logic is all stored within the CAD model. There's no need for further plugins or external resources. Once done, we can see the resulting files of the latest configuration we created, complete with the additional step output. The Solid Edge Design Configurator creates new design iterations at the click of a button, dramatically reducing the development time for creating customized products.